Hello everybody, today we're going to be building our own lottery project in Solidity. Let's begin with a Chrome tab. In this Chrome tab, I just want you to go ahead and go to Remix IDE. When you search this up, it should be the first one. It loads, awesome. Yeah, sure, we'll help you improve. So the first thing that I like to do when I start working on my Solidity project is I really like to work on a clean workspace. So up here on the top left, you could add click on this add workspace button. It's like a little plus sign, and then we'll just give our project a name. We'll call it lottery. Why can't I spell lottery today? Haha. Okay, so we clicked on lottery, and in here in workspaces you'll see that it's selected. Once the workspace is selected, we could go ahead and really delete all of these things just so we could have a clean workspace. Don't worry about it, it's not gonna influence in any way how we do things in this contract. The one thing I will do though is go ahead and copy paste these two tabs from these two lines from any contract there. They're just needed. Okay, let's delete this readme file. Okay, so now you're gonna click on contracts, and then there's a little file icon right here. This will allow you to create a new file, and we're gonna give our contract a name, lottery.sol, which is the extension for our Solidity program. Awesome. So we have these two lines. And these two lines are always going to be needed in our Solidity contract. And basically, let's go over this first line right here. This is going to be the license for the program, and this is always the first line in your Solidity file for the most part. And following that is the pragma Solidity, and basically this is letting the compiler know what version of Solidity you're going to be using. And here we're giving it a range from 0.7 to 0.9. Currently, I think at the time of this recording, we're on version 8.4, 0.8.4 or something like that. Anyway, that's the version that we're going to be working on today. Once you have this selected here, you can click on this Solidity compiler here on the left. And here's where you'll compile your code. Next, let's declare a contract. Contract lottery, opening and closing curly braces. And what this is going to do is that it's going to declare a contract named lottery, just like in any other language. Instead of saying class, you name it contract. It's not the same concept, but it's very similar. Next up, in a lottery, we need kind of like a set of players, but in this case we're going to make it an array of players. And to do that, in Solidity everything is categorized like in categories, right? So whenever we speak about people or wallets or contracts or external accounts in Solidity, we refer to them as addresses, because we're going to refer to them to their public addresses. So we're going to create, and this is just how you create a dynamic array of addresses in Solidity. Okay, so let's break down this line of code. This is of type address, which is basically established for any it's kind of like just the public hash that is given to each wallet, so the public key. And then we're declaring it an array, or in this case a dynamic array, and it's of type public. Awesome. Next up, we're going to create our admin. Okay, we see this keyword payable again, and I didn't really go over it in the last line. What payable means, it means that this is an address, and in this occasion this address, you could transfer money to it. So this allows the contract to really transfer any sort of amount to this address. Awesome. Let's move forward. So next up, we want to create a constructor. Okay. In the constructor in Solidity is called only when the contract is deployed for the first time. So the only thing that we want to do here for now is that we want to make our admin equal to the person who deployed the contract. And we want to make whoever deployed this contract the admin of this contract. This is a good practice because this will allow for more safety features to be added down the line and any functions. So it's kind of important. We go admin is equal to msg.sender, and this msg.sender is a global variable that states who is deploying this contract. I'll write a little note here for you guys. msg.sender is the public key or address of the person that deployed contract. Now, just as a disclaimer, I keep referring to this as a person, but it could be another contract as well. Awesome. Next up, we want to get the balance of this contract. We will need it in the future, so that's what we're gonna need to do. And just to kind of set the right expectations, what this maybe I should have said this sooner, but what this contract is going to do is that, like any lottery, whoever wins the lottery gets the full amount in the lottery. There is a way to obtain the full amount that a contract holds. Okay, if you know anything about blockchain or Ethereum blockchain, there are two types of accounts. There is an externally owned account and a contract account. A contract account can hold the balance just like an externally owned account can hold the balance as well. Having said that, this contract account can have Ether sent to it, and then you could really just, whoever the owner of this contract is, or the contract itself, can really do whatever it wants with it. So we're going to need this later on when we declare a function called pick winner, because the pick winner function is going to allow us to send out the balance of the contract to the winner. Great, so let's go ahead and do that. The way we declare functions in Solidity is the following. Function get balance. Awesome. We want to make this a public function, and we want to make sure that it returns a type of unsigned integer. Awesome. Opening and closing curly braces. And what this is going to do is that this is going to return an address, this instance dot balance. Let me explain this line of code. Address of this is referring to the instance of the contract itself, of this deployed contract once it is deployed. Let me just compile this to make sure everything's okay. Oh, we have an error here, and I'll go back to it in a second. So here in this instance, this is referring to this instance of the contract, and the dot balance is kind of just a global variable that we can refer to. I'll probably go more in depth into global variables in a future video, or I'll probably just paste all the global variables down below in the description below, or I'll give a reference to the Solidity documentation so you guys can take a look at other global variables. But whenever we say balance, address of this instance balance, this will return the contract's balance. Awesome. So now to fix this error here, and the reason why Solidity, or should I say Remix compiler, is screaming at me right now is because I forgot to declare this a payable address. So right now when we declare admin, it's just a regular address because message.sender is a regular address. We want to make message.sender a payable address, and the way we do that is by casting it. We go payable, opening, closing, and then this is going to cast it into a payable address. Awesome. So let's go ahead and compile this. Awesome. So here we get a warning, and what this is saying is that function state mutability can be restricted to view. What does this mean? Well, in Solidity we have different things. So every function can cost gas. So in this case, this is just a call function. There's a difference between a call function and other types of functions. So if I were to go and make a call to this is not really changing anything in the blockchain. What that means is that any change that you make to the blockchain cost gas. So having said that, this doesn't really make any changes. Any call that you make to the blockchain is free. So that's why we declare this a view. Okay, and making this function a view function means that this function, when called, will not cost us any gas. Awesome. There are other types of functions that do cost gas, and I will cover them as we go. I will also reference to a documentation that shows really how much gas each thing spends. Great, moving forward. Next up, we want to create an essential function in any contract that's going to receive a balance. And when I say essential, I mean essential. So it's called the receive or fallback functions. In this case, we're only going to create the receive function. Let's just code it out and I'll explain it in more detail. Okay, now what this does is that it allows for, oh, this is screaming at me. Why are you screaming at me? Let's check why this is screaming at me really quickly. Just wondering. Cut. Oh. Okay, welcome back. Turns out I just misspelled receive, and that's why it wasn't working. But it works now. Okay. I'll just drink some coffee. Okay, so we need this function. Whenever we get this function, you need to include it into any contract that is going to receive some type of balance into the contract. This is the function that will handle all incoming Ether into the contract. So now that we have this, we can send Ether to this account. Now we compile it and everything seems to be working. Awesome. Now let's go ahead and deploy our contract. The way you deploy your contract in Remix is the following. Up here in environments, I like to use the JavaScript VM. You can select any of them. I'm just gonna go over Berlin. Down here in accounts, you'll see a list of accounts that you could choose from. I'm going to select the first one. Once you click deploy, you can deploy your contract, and you'll be able to see the contract down here at the bottom at deployed contracts. We're gonna click here. Awesome. So right now we see one thing, and it's the get balance. So we're gonna get balance, and it's going to return 0, which is the default value for any unsigned integer. We have not sent any balance to this account. So here's what we're gonna do. We're going to copy over this address into our clipboard, and we're going to select a different account. Here, we're going to add a certain amount of ether, and we'll select 5 ether. Now we can go to add address, and here's the address, and then we're going to transact. Once we transacted or completed the transaction and we click get balance, we'll see the amount of ether that we have here. And the reason why it's such a large number, it's because the balance is returned in a unit called way. Way is one of those kind of like it's a unit that's smaller than ether, so it kind of breaks everything down a little bit. This is beyond the scope of this lesson, but I just wanted to go over that. Okay, moving forward. Now that we see how everything works, I realized down here that we never created a getter function for get balance, and this is something that Remix does for you. It creates getter functions for anything that you make public. If we notice up here, we never made the admin public. So we're gonna do that right now. We're gonna say public, and we're going to come back here and compile. Once we do that, I'm going to close out this tab of the contract and trash everything so we have a clean workspace. Then we're going to go to the first account. It doesn't really matter what account you're doing it with, but I just like the first account. And we're going to deploy it. Once it is deployed, we'll click down on it, and we can select the admin. And right here, you'll see that this is the same address from up here. Awesome. Okay, moving forward. Next up, we have to generate the random function. And what this is going to do is that it's going to allow us to generate a random number so we could select a... Okay, so let's break down this function. It's a function called random. It's of type interval, and we see this view once again. What does this mean? Interval means that it can only be called within the file system. It cannot be called by any external source. So when we compile this, and let's just go ahead and do that, we'll see that if we deploy it, we'll see the last deployment down here. We don't see the we don't see the function here, and it's because it's of internal property, and this is only allowed to be seen within the file system. More about this in future videos or in future contracts. This view property right here just means that we're just viewing something, we're just making a call. We're not really making any changes to the blockchain. It returns an unsigned integer, and this is the call. Okay, so let's break this down. Basically what this does is that it takes properties of a blockchain alongside with the player's dot length, and that is the length of this dynamic array right here, and it encodes it and creates a random integer based on that encryption, you could say. Now I'm not going to go into detail about how this function works. That's beyond the scope of this lesson. So if you'd like to see more, you could follow up with the Solidity documentation for that. Next up, we're going to create the pick winner function. Now, moving forward to the pick winner function. The pick winner function is the bread and butter of this contract function. Pick winner. And the pick winner, we're gonna make this public. Oops, what am I doing here? We're gonna make this public. Sorry guys. And then voila. So what do we know about this? It's a function. It's called pick winner, and it's public. Awesome. Now, here's a requirement that we need. Only the admin can call this pick function, this pick winner function, I should say. Why? Because we don't want just anybody picking a winner. Only the admin can decide when the lottery is going to be picking a winner. So let's just go ahead and do that. And the way you do that is you go require admin. Oh, sorry. Admin. What's going on with my typing today? Admin equals message.sender. What this does is that it's basically an if statement that if it's false, then it breaks away from the function and it doesn't continue. If it's true, then it just continues with the rest. Now, a good practice is to put a statement just in case it is false. So this is what it's going to say in case it's false. You are not the owner. Awesome. So let's go ahead and compile this. So it's telling me that right now it can be restricted to view, but I'm not gonna change it to view just yet. Okay, so moving forward, let's go to the first account, just like I told you guys before, in the environment JavaScript VM Berlin. And here, what we're going to do is that we're gonna clear all deployments and then deploy this. The contract is down here by deployed contracts. And then we're going to see the admin. The admin is this 5B3 account, 5B3. And this could pick a winner. And if we look down here on the console, it gave us a green check mark. Let's select another account. Let's select account number 3. We haven't paid any attention to that account. It's lonely. So now that we interact with the contract and we try to pick a winner, what happened? It's not working. The reason why it's not working is because it says transaction has been reverted to initial state. Reasons provided by the contract, you are not the owner. So we see that whenever there is an account that is not the owner, it doesn't let them pick the winner. Awesome. This is exactly what we wanted to do. Now, another thing that we wanted to do is that it should not be able to pick a winner unless there's 3 players currently participating in this lottery. So let's see. Require keyword once again, and we go players dot length has to be greater than or equal to 3. Voila. So now if the players have if the player array has a length of greater than or equal to 3, then this will allow it to proceed. If not, it's gonna break off. Awesome. So let's just give it a little, if it doesn't work, type of deal. So not enough players participate. I don't know how to write participating. Wow. Participating in the lottery. Awesome. Okay, now next up, I want to declare the winner. And I don't just mean declare a winner. I mean, let's declare an address of type payable, because we're gonna pay this winner. Okay, and this is going to be the placeholder. Now, if you're familiar with any other programming languages, then you shouldn't have a problem with this following line. Winner is equal to players of random modulus players dot length. Now let's go over this line of code, because this is kind of new. We haven't done this yet. What this does is that this random function is going to generate a very large number, And when we combine it with the modulus operator, that just gives us the remainder of that function based off the players.length. If you're not familiar with the modulus operator, I suggest you look for it online, or you look more in depth. But basically a brief explanation of this is that if you go 5 modulus 2, this is going to print out 1. And this is just means that 5 divided by 2 is 2, and then it's always going to give off the remainder. So having said that, we're going to use the players.length to give us a number from 0 to players.length minus 1, really. So if players.length is 3, it's going to give us a length of from 0 to 2. You know, so if there's 3 players, and it's going to be from 0 to 2. Awesome. So this is going to pick a random person from the players array. And now that we have that, we want to transfer the money to this person. And that's very easy in Solidity. It's going to be winner dot transfer. Transfer. And we want to transfer the entire balance of the account. And we're going to go get balance. And this should be it. So what's happening here? Why isn't it working? Okay, let's see. Did you mean players? Oh, we misspelled players here. Okay, awesome. Go next. Now, this is a very basic way to create this contract, okay? And last but not least, we want to reset this lottery. And how do we do that? Once the winner has been selected, we want to make sure that this players array is resetted. So players is equal new address of payable. And this is just how you declare a dynamic array into basically like a new array. Okay, this transfer function is goes off of any winnable address. So when we do dot transfer and get balance, then it's gonna work. So that's gonna transfer all of the ether on the contract to that account. Let's see how it works. Let's go ahead and deploy it. So we compiled it, everything's working. Okay, so let's go to a first account. I like the first account and deploy it as the admin. Okay, if we do get balance, we have nothing yet, but I'm just gonna go ahead and send anything to it, right? We'll send it 10 ether, and we have to copy the address of the contract and paste it here, and then transact it. Awesome, it's done. Forget the balance, we have the 10 ether right here. Okay, so let's go back a minute. How do players participate in this? And what we want to do is that for them to participate, they have to send a certain amount of ether to this lottery to be able to participate. And the way we do that is by adding a require statement here in the receive function. So we're gonna go msg.value has to be equal to 1 ether. Awesome. If they do not at least deposit 1 ether, or in this case exactly 1 ether, to the contract, they will not be able to participate in the lottery. Now let's make something else. Let's make sure that the admin cannot participate in the lottery, because this would be unfair to everybody else. msg.sender cannot be equal to the admin. What this does is that it makes sure that the admin does not take part in the lottery. Awesome. So now that once that's done, we want to make sure that we push this new change to the players array. Done. So now, once again, we have to cast the address of the msg.sender to payable. And what this is doing, let's go over these lines of code, because this was kind of quick, right? So first of all, it's making sure that the msg value, which is the value that's coming into the contract, has to be at least 1 ether, or in this case, exactly 1 ether. Okay, next, it requires you that you are not the admin, right? So just like before, let's add conditions here. Must be exactly 1 ether. Awesome. And then boo, admins can't play. And let's just write admin, because there's only one admin. So this is done. Okay, let's clear the contracts and let's watch the magic happen. Right here, once again, select the first account, we'll deploy it, and okay, awesome. So let's try to make sure, let's see if the admin can send money to this. 1 ether, and we'll copy over the address, and we'll try to transact, and we got an error message. Boo, admins can't play. Awesome, so that works. Okay, so let's just go ahead and select a different account. We'll select the second account. Okay, and then we'll do 1 ether at address, which was the address that I copied over from here, and let's transact it. Awesome. So now over here in the get balance, we should see 1 ether. And if we go to players and we press of 0, we should see that 1 player that participated in the lottery. Awesome. Moving forward, let's select a different account. 1 ether. Add address of the contracts. Bam, successful. So now let's check. It should be at 1, right? Cool. Okay, we should be able to select a winner now. Pick winner. Oh, what happened? Oh, I see what happened. There's not enough players to participating in the lottery. Remember, guys, we need at least 3 players participating in the lottery. Let's go back and add another player. Account number 4. Once again, and last time, 1 ether. And add address, and then let's press transact. Awesome, it's working. And now let's make sure that player is added. Player, in fact, is added. So now, let's go to the admin account and pick a winner. Oh, winner was successfully chosen. And let's get balance. What happened? It was 0. There's no balance left. Let's see what account got all of the transaction money. It seems like this 4th account, or 3rd account, whichever way you're counting, got the most balance and was the winner of this lottery. Okay. Now guys, this is very basic. I really hope you guys learned something from this. I will set a number of challenges. I urge you to look at a way to make sure that, let's write out this challenge, right? A way for the admin to keep 10% of all incoming transactions. That's this video's challenge. Okay, make it so that the admin can get, I don't know, 10%, 20%, 30%. I don't know how greedy you want to be. Okay, now this isn't my GitHub repository. Link in the description down below. You could always check it out. There will be the full project with some added features to it. If you're curious and you're wondering how I did them or where they're coming from, I urge you to look through the Solidity documentation. It is the best way to learn, guys. When you struggle to kind of see how something works, that is the best way to learn. So I really hope everybody learned something today. I wish everybody the best of luck.